This video covers how it is that marginal abatement cost curves can be used to explain firm decision-making under different economic instruments. This video will focus on firms and their decisions to reduce emissions. I will follow up in the next video by extrapolating these ideas to landholders and tropical deforestation. So to begin with, we have the same marginal abatement cost curve that you've seen in a previous video. Notice that emissions increase from the origin and that cleanup increases in the opposite direction, that is, as we reduce emissions. What we're going to add to this example is a per unit tax. And what we have here is a per unit tax of $20 that's imposed on each unit of emissions that the firm emits. So the firm's allowed to emit as much pollution as they want, but they do need to pay the tax for each unit of pollution. So that per unit tax is set at $20. And what we want to think about is how it is that the firm is going to make decisions about the amount of emissions that they'll be emitting under this scenario. Okay, so the firm is going to be starting at an emission level of 10. And notice that at 10, they have no cleanup. So they need to think about, should I reduce emissions from 10 to 9? That first unit of pollution is going to cost me $5. So the marginal abatement cost of cleaning up that very last unit, the first unit here in this case from 10 to 9, is 5. But notice that the firm can reduce emissions in between 10 and 9 as well. So far in the previous examples, I've made the assumption that we can only reduce emissions in whole unit amounts. We're going to take that a bit further here and assume that the firm can reduce pollution by a small amount to 9.9 units, 9.8, 9.7, and so on. So what this means is that the total cost of cleanup of going from 10 to 9 is all of those micro units added up together. So if you look at that area, what we have actually is the area of a triangle. So the total cost of cleaning up that first unit of pollution here would be the area there of that triangle, 1/2 the base times the height of the base here is 1, the height is 5, so we get a total cleanup cost for the first unit of pollution of 2.5. So what the firm's going to do is compare that total cost of cleanup to the tax. And in this case, what we have is a cleanup cost of 2.5, a tax of 20. So we would assume that the firm will clean up that first unit because it's cheaper than paying the tax. So once they've cleaned up that first unit, they need to think about whether they should clean up the second. Notice that the total cost of cleaning up that second unit of going from 9 to 8 would be the area underneath that marginal abatement cost. Again, we're allowing for micro units of cleanup. We're going from 9 to 8.9, 8.8, and so on. We get the total area underneath the curve is the area of this little triangle on top and the rectangle underneath. So we get a total of $7.5. You can think about this as dollars or thousands of dollars or millions of dollars. But here, for simplicity, we'll just say it's $7.5 for that second unit. And the firm would compare that to the total tax they'd have to pay for that second unit. So here, the firm is comparing 7.5 to 20. And again, we'd assume that the firm would clean it up. It's cheaper than paying the tax. So let's take that one step further. Should we clean up the third unit? If we did that, we would be comparing that area underneath the curve between units of emissions of 8 and 7, cleaning up 2 to 3 units. And here we get 12.5. Comparing that to the tax, we get a comparison cleanup costs of 12.5, a tax we'd have to pay if we didn't clean it up, and the firm here would decide again to clean it up. It's cheaper than paying the tax. Take it again, one more unit, we'd clean up 4 units, reducing our emissions here from a total of 10 to 6. That fourth unit would cost us $17.5. Again, we're adding up the area of that little triangle on top and the rectangle underneath. The firm would be comparing that to the tax they'd have to pay if they did not clean it up. And again, we'd be at a situation where the cost of cleaning up is 17.5 and 20, which is lower. So the firm would decide to clean up that fourth unit, again, because it's cheaper. And finally, let's take a look at this last one. So as we move from 6 to 5 units of pollution, reducing from 6 to 5, one more unit, notice it's visually obvious that this is larger than the tax. If we take a look at that area, we get an area of equal to, again, adding up this little triangle on top and the rectangle underneath, it's 22.5. So the cost of cleaning up that fifth unit is 22.5. The firm would compare that to the cost of paying the tax, which is 20. And in this case, the firm would decide not to clean up the fifth and not to clean up any further, because any more than 5 is going to continue to increase the cost of cleanup. Again, it's cheaper to pay the tax, so the firm would choose to stop cleaning up at 6 units of emissions or 4 units cleaned up. So what we see more generally is that the firm will stop cleaning up when the marginal abatement cost is equal to the tax. What we can conclude from this is that a firm is going to reduce pollution when it's cheaper to clean up or abate than to pay the tax. Second is a firm is going to choose not to reduce pollution if it's cheaper to pay the tax than it is to clean up. And therefore, a firm is going to clean up until the tax is equal to the marginal abatement cost. And what this means is that if all firms clean up until the tax is equal to the marginal abatement cost, that the marginal abatement costs are going to be equated across firms. In other words, the marginal abatement cost of firm 1 is going to equal the marginal abatement cost of firm 2 and 3 all the way to firm number n, if there's n number of firms in this market. This is what is known as the equimarginal principle. When this principle holds, we will arrive at the cheapest way of reaching an environmental target. This is the most cost-effective way to reach an environmental target and something that we'll discuss in future videos.